Hi, I'm Dong Wai, Standards Architect and Fellow at ARM. Today, I'm going to talk about what's new in SystemReady, hardware certification for software that just works. We're going to talk about the SystemReady bands. We're also going to talk about the updates to the specifications and test suites, certification requirements and processes. We also identify major compliance issues and what to do about it. The SystemReady and PSA are two different programs. We're going to talk about its relationships. And then at the end, I will be talking about the devices that have been certified and how you can get involved. The SystemReady bands. So we have initially worked on the standards approach to get software just work on ARM-based devices for the servers. But over the last year, we have extended into the edge and IoT space. The major purpose is to land common OSs on top of everybody's hardware and firmware solutions so that we defragment the market. The approach that we have been doing is that we don't want to go to the fixed standards where no flexibility can be landed. We also don't want to leave everything to customization, which will result into high software maintenance costs. We are trying to strike a balance in the middle. We establish the standards as a minimum requirements, and then we also enable innovations on top. So the approach that we have been doing is that we look at what the market segment requirements are and what the operating system requirements are also. So initially, we started at the server side, right? Just works on servers or workstations. And in that case, we supported the SR band where multiple operating systems, Windows, VMware, Linux, BSD, all these OSs can work on top. And we support old OSs to run on new hardware and vice versa. We, of course, also target the generic off-the-shelf OSs. We ensure standards firmware interfaces are available to deploy and maintain. We extend that into the embedded ARM SoCs as well with the new ES band for the ARM SoCs. In addition to that, we also created the IR band where the JustWorks approach is going to work for Linux and BSD on embedded ARM SoC devices as well. This is for embedded Linux ecosystem, assuming the mainline Linux support is already available for the SoCs. This is targeting both the customized operating systems like Yocto, OpenWRT, built-root, as well as the pre-built distros like Debian, Fedora, SUSE, and Ubuntu. We also created the LS band for the Linux OSs running on server systems. This is mostly for the hyperscalers, targeting hyperscalers' Linux environment. So the specification and test suite updates that we have done over the last year, basically we have these three key specifications. The BSA, the base system architecture, is establishing the hardware baseline for all market segments. We have done the specification last year, right, at the DevSummit. We also have the ability to create a supplement hardware requirements for different market space. We certainly have the server BSA, which we updated into version 7.0 in January. And we are looking at enhancing the ability to address the automotive market as well with the embedded BSA for real-time and safety processing requirements. We also have the firmware base boot requirements document, which actually expands to include the common firmware interfaces, but recognize that we would need to address different software stacks with different recipes. So today we have the SBBR, EBBR recipes to address different operating systems and environments. We are also working on creating the LBBR for the Linux boot environment as well. In addition to that, eBBR is also a specification that we have been developing with the community. We have the BBR spec refer to the eBBR as needed for that particular recipe. We have updated the eBBR spec in August, and U-boot is basically following the eBBR spec very nicely. So you can check the U-boot mainline and the eBBR support, which requires a reduced set of UEFI interfaces, are there. And we created the base boot security requirements BBSR document to address the secure boot and firmware update interfaces. We actually updated the spec in June of this year. Of course, CXL is becoming a very attractive technology for the server market. We are working on CXL on ARM integration and design. We have a guide document to provide the guidances on building SoCs that present CXL compliant systems and boot requirements. This is under review in the System ArchAC, which is the forum that I will talk about a little bit later. And then this also is becoming the precursor to the CXL requirements in the next version of SBSA and BBR spec. Speaking of the System ArchAC, this is the System Architecture Advisory Committee. This is the forum where partners signs an NDA with ARM, and we work with the partners to create the standards that we mentioned. And in addition to the standards that we mentioned before, we also include the server-based manageability requirements spec in this discussion as well. So this consortia basically has more than 50 companies, partners that we work with. This includes silicon providers, OS vendors, IP providers, OEM ODMs, firmware vendors, hardware vendors, software vendors, and hyperscalers. We created a few sub-teams to concentrate on specific topics with the subject matter experts, and then we can work on the engineering change requests that can be reviewed and approved to be adopted into the newer version of the specifications that we just mentioned. And this slide, I think we talked about this, last October at the DevSummit, right? And this is the meat of the SystemReady program. It's kind of like a cheat sheet where it shows you, what each of the bands are based upon, the hardware requirements, the firmware requirements, what type of operating systems they're supporting, and for the BBSR, the security interfaces, which bands are actually going to be able to apply and so on. And then typically, what are the firmware interfaces that are exposed on those devices? So this is the one sheet that you want to always carry with you. It's a nice summary of what each of the bands are about. So not only we need to have the specifications, right? We need to figure out how we test the compliances. So originally we have this enterprise ACS for the server space, but we realized for all these 4 bands, we need to restructure the architectural compliance suite, the ACS, into a modularized approach to check each of the part of the requirements, and then they can mix and match into different bands. So today, I am ready to announce that we have the IR ACS version 1.0, and it's going to be used in the newer version of the IR certification. Similarly, the ES ACS is also having the version 1.0. And on the server side, we are continuing to use the enterprise ACS. We have a new update, version 3.1. But toward the end of the year, or maybe early next year, we are also going to make the SR ACS to follow the modularized approach as well. So you will see an updated server SR ACS following the same modularized approach. In addition to that, we also made the ACS for this SystemReady security interface extension based on the BBSR spec as well. So I'm announcing that the release 1.0 version of that spec and the test suite is also available. we're going to be able to support the certification for devices that support these BBSR interfaces. So certification requirements and processes. So we do have a document called SystemReady Requirements Specification. I have updated that to a new version for this DevSummit. Basically, if you look at the 3 bands that we're ready to certify today, we have made some updates. On the SR front, basically we're requiring the WinPE to be tested as part of the OS installation and boot logs. And then we are using the new version of the ACS, right? And so we are also, of course, requiring 2 Linux or BSD distros in addition to that. And the ES front is similar, but in this case, we're requiring the VMware ESXi, ARM Fling to be the OS that's required to be installed and booted, and the logs to be sent to us. And in addition to that, 2 Linux distros as well. We also created these waiver levels that I'll be talking about a bit later, because in the edge and IoT space, the current generation of SoCs are not fully compliant to the BSA, and we have different ways to address that. So I will have some details later on. On the IR front, we are requiring 2 Linux distro or BSD distros. We recommend Fedora, Debian, OpenSUSE, and Ubuntu. And also the waiver levels, I'm going to be talking about that as well. This interface is checking the BBR compliance plus the device tree support. We ask you to run the BSA test, but we are not enforcing it because I think part of the issue is that the current generation of the SoCs are not compliant. So the certification process, this is an overview. Basically, if you have a device ready to be certified, you contact us. We work with you and maybe some of the test labs as well to run the test, to collect the test results, and then we will do the evaluation. And if everything is in good shape, then we would issue the certification. And there are waivers that could be applied as well when there are issues, right? So I'm going to talk about that as part of the waiver levels. So this is a very simplified version of the process. I do have a more detailed chart about the processes in a lot more details, how everybody worked together to get this done. And I attached that as part of the backup material for this presentation that you can check into. So throughout the year, we have been able to identify some of the major compliance issues, and I'm going to also talk to you about what ARM plans to do to address some of that. These are the major compliance issues. First one is the PCIe ECAM compliance. On the edge and IoT space, the current generation, we have found most, if not all, of the SoCs are not compliant to this standard. So this is a hardware mechanism for OSs to find PCIe devices through the PCIe configuration space. So we have some alternatives. Alternative one is that we have defined a standard SMC interface for the access, especially for the SoCs not able to support the ECAM. VMware and NetBSD are, supporting this, and actually VMware is requiring this. We would like to see other operating systems supporting this interface as well, because that allows you to expand the market to use, a lot of the SoCs in the market without doing an alternative 2, which is the per SoC quirks. That assumes the SoC support will need to be in the mainline Linux or other OSs for each of these SoCs. The non-compliance is very different on each of the SoCs. So in that situation, the software just work is not actually doable. You actually have to support these quirks for each of the SoCs. And then the UART is also a commonly seen problem. The BSA spec allows for the ARM generic UART as well as the 16550. But the issue is, although the ARM generic UART has seen no issues, if you get to the PL011 from ARM, this is the safest choice. But if you happen to use other IP to support the 16550 UART, even though in theory they should be BSA compliant, but so far we have not seen any SoC integration of third-party IP that is fully 16550 compliant. So you have to, again, do the quirks into the OS, and that results into this promise of software just work not being available. There are other issues like wake-up timers, watchdog timers, peripherals like USB host controllers, interrupt controllers, and some of the standard interrupt numbers support. They are not compliant to the specification like BSA and SBSA. So these are creating a lot of pain for getting the software to just work. So one approach that we are doing is that we are having this pre-silicon BSA compliance program. This is key to SystemReady and software that just works. We check the compliance before tape out, and then this is in addition to the design verification. We test for the BSA compliance during the pre-silicon phase. We develop the compliance test suite, this ACS, for the bare metal, and then we collaborate with the EDA vendors for this nice experience. So we are currently engaging with a limited number of lead partners to this program, but the wider commercial rollout is also being planned. Like I said, the testing for the pre-silicon BSA is a significant part of the journey to become system ready. We basically inject ourselves in the middle of this journey to allow silicon providers to test for pre-silicon BSA compliance before taping out. This is very important because if you find out problems after tape out, then either you have to live with a lot of these problems and not able to certify, or a lot of trouble, firmware workarounds and all that. That's going to be very costly. So the approach that we're doing is, we provided the compliance test suite ACS open source. We developed that. We work with the EDA vendors or silicon providers to do the pre-silicon compliance suite, integrating the ACS drivers, exercises for this environment. And this is co-developed with the EDA vendors like Cadence and Synopsys. And then the silicon vendors would build their SoCs and verify the compliance through this environment. So this is the Cadence approach, right? So this enables the PCIe and exerciser rule checks that are only possible with bare metal and require controllable endpoints. So this is a very nice capability from the Cadence solution. And then similarly from Synopsys, we have worked with them on this verification solution. And that includes the compliance ACS test suite, some of the C models for system realization, bring up assistance, and also performance validation capabilities. So this is actually going to be available and built into the native supported ZeBu environment as well. So, and then, like I mentioned before, the PCI configuration space access firmware interface, we standardized that. This is actually permitted by the PCIe base specification. We have a beta spec published in June, and we have been working with a lot of partners already. TFA, for example, has the patches accepted upstream. Raspberry Pi EDK2 is supporting that. Future Raspberry Pi UEFI implementation will have the support enabled. The FWTS test, this runtime test suite is also providing this additional interface testing, and it's accepted into the latest upstream. NetBSD also supported this interface and added that into the future release, the 10.0. And then VMware CTO Kit Colbert actually provided this nice quote that in addition to VMware supporting the SystemReady program, they are very interested in the non-server environment as well, and they see this firmware interface PCIe config space access to be very critical. They would like to require all the SoC vendors to support this new interface. And I touched on to the waivers, right? So like I mentioned, most, if not all, the SoCs in the current generation for Edge and IoT market are not BSA compliant quite yet. So we would like to certainly have all the certifications to be done to level 2, which is everything is compliant. But we found that the SoCs are not quite compliant. So one possibility is to have hardware firmware workarounds that result to no additional OS changes needed. In that case, it's level 1. But if you run into a situation where the OS change is required, that's even worse, right? And so that situation, we have level 0. So for level 0, we need to see evidence that the OS changes are actually in place. Maybe it's upstream, maybe the fix is available in the alpha, beta nightly builds for the open source. And also in the commercial OSs, we need to make sure the fixes are going into the OS distro, or you have a way to inject the OS level drivers for the fixes. So anyways, we have these different levels, and right now all these 3 levels are available. And at certain point, we're going to deprecate the level 0 and level 1 based on the market conditions. So SystemReady and PSA, these are independent programs right now. And in addition to that, we also have the base manageability requirements for the servers, and it may get into the Edge and IoT space also. And if you think about the way to certify both PSA and SystemReady, here is the connection that you can see. You need to make sure the silicon is certified first, and then you get into the SystemReady certification for the firmware, and then combine it with the operating system, you can certify for system software and device. So then lastly, I'm going to show you the certified devices. Here is a list of all the SystemReady supporters. Thank you very much. We really appreciate the strong support from the community for the SystemReady program. And Microsoft, as always, they have been supporting this program from the very beginning. And SystemReady is the first step toward enabling Windows for both Azure and IoT devices. And if you're interested in enabling your IoT devices, there is a link, email link at the end that you can use to contact Microsoft and ARM. Here are the certified devices. We have certified quite a number of devices. I think if I count it right, it's 19 devices overall in SR, ES, and IR bands. So this is doing great. Thanks very much for all the vendors who have been working with us very diligently to get these devices certified. Here is the pipeline. We have additional devices from these companies that we are almost going to be able to certify. And we work with these companies very hard right now. We also have NVIDIA supporting the SystemReady program. NVIDIA Jetson brings accelerated AI to the edge in a power-efficient and compact form factor. As a supporter of the SystemReady program, NVIDIA is working towards enabling a greater selection of Linux distributions support on Jetson and future ARM-based systems, bringing additional value to customers and the developer ecosystem. Thank you, NVIDIA. And as I mentioned, there are a lot of devices that are currently under work for the certification. So if you want to know the latest and greatest, check on these lists for the devices that are certified. And SystemReady certification provides the confidence that software just works on these devices. So to get started, here are some of the links that you can get to, the website, the email addresses that you can contact us. And for the DevSummit, there are other SystemReady related sessions that you can go check out. And of course, there are some keynotes that may have a lot of mentions for the SystemReady as well. And thanks very much for your attention, and have a great DevSummit. There's a live Q&A session starting now to continue the conversation. To take part, join us on Zoom by clicking the yellow button just below the video player on this session's page.